Hey everybody, hey Sarah. I didn't say hey to Sarah in the chat, I was doing the effects. Good morning, Evelyn. Just hanging out this morning on the 80s. I just like this song. This is like my new song. Throwback Thursdays. Dan knows some Throwback Thursdays. I turn it up. This is all wrong on this screen. I need to fix this. Why are all these events wrong? Every event goes to Monday on this screen. Well, that's just Throwback Thursday. It works on the other screen. It should work on the other screen. I don't know why on this screen it has all the problems. What questions do people have? As I check out my setup here. See, why does Crash work on this screen? I remember that. Throwback Thursdays right there. What questions are there? I'll turn down the music here. What are people working on? What questions are there? We will do all the statistics. We could do, hey, what's up, Kayla? I've got the intermediate R pulled up. A bunch of different things right there. It's like hype music. I thought I had it pulled up. Where is it? Well, I'll be. Well, I can't find it now. I lost it. It's all lost. Nothing right now, Dan. Just started office hours, just hanging out at the moment, trying to see what people want to go over. So feel free to pick anything you want. Can we go over? Yeah, of course, of course. It's really good practice for what's to come and understanding. And all these, like, it's kind of neat. I'll be referencing these videos to people saying like, hey, check out this portion if anyone's wondering for any of the future visualizations. And it kind of, we can use this to talk about like what we'll be covering. So I'm totally open to that. Let's go to visualization. Remember, you're here. You get to, it's like a game where you get to control the board. So visualization number 6, decision trees. My gosh, we will have so many visualizations done. Let's see. Let's hop back right here. I know, right? The problem I was asked about Discord wanted me to use the Jamie. Here, we're gonna do Jamie's question first here. Oh, thank you, Dan. Thank you, Dan. No. That's the way to do it. Let me see Jamie's question on Discord right here. We're gonna do that one first here. And where's the question, Jamie? Jamie says the problem I asked about on Discord wanted me to use the oh, I know what you're talking about. You're talking about and let me pull up Jamie's question right here. I know which one you're talking about. We were talking about this in the conversation. So let me see. I'm going to find Jamie's question. Sorry. I'm looking for the conversation with Jamie. But the wrong person. So many people. No, I can't. Which one? I'm trying to find. 2 seconds, everybody. If I return all the values in the vector that follows the data file, which one can you post it here, or can you post it in the B? I am Disney. Oh, that's who you're. Yeah. That's why I couldn't find your name. That's it. 2 seconds. Okay, now I'm finding it. Okay. Do you mind if I screenshot it and then bring it over? So it said it wanted you to use the $sign. Okay. So I'm going to screenshot this here and bring it over so we can talk about this problem right here. Do you mind? I think you'll be all right. Just be like, yeah, that's okay. Or no, don't do that. Okay. Yeah. I was 99% certain. I just want to ask before I bring it over. Okay. There we go. Let's talk about this problem right here. And thank you. This makes it really easy. That's why I like having the Discord, because then it's easy to find. Okay. So this one right here, the data set is preloaded into the data set in your workspace. And this is this is a solution to the problem right here. This is the one I sent over back as a picture. Select the second column named this right here from this. And so there's 2 ways to select columns. Let's kind of show the 2 ways to select columns right here. When you have a so when it says it's already preloaded in, it means this right here. So the very first thing it says is it's preloaded in. So since it's preloaded in, it's already in your global environment, like it exists as preloaded data. Does that make sense right here, Jamie? That this right here is preloaded in, so you don't even actually have to run this. This is going to be preloaded in. It's like it exists, just nothing needs to be done. The data's already there. So that is what the very first line right here means. The data's there. Don't worry about it. So we're good on that one. And then the next one, select the second column named day 2 from the data set right there and store it into second. So name day 2 from, and so it wants you to store it into second right there. So we're going to do a very similar thing right here. We're just going to store into second, and we're going to select the second column. So there's a lot of ways to store the second column. You can use the $sign, and you can see this is the name of the second column right here. So here is the second column. This will store it into second, and we're going to just clear it out so we can only see what matters. You can see the second column is stored right there, and if I remember correctly, you were doing it a slightly different way, so I'm going to show you 3 ways of doing it. You can use positions, and can anyone figure out, 320 folks, what is a way to do it right here with the positions? So let's make it bigger again. What is a way to store the second column with positions? There's 2 ways I'm going to do. I'm going to store the second column right here. What are 2 ways? And if you can code something 3 times, you know how to do it. Don't worry about coding it 3 times. You only need to know 1 time. But the more ways you know how to code something, the better off you are. Kayla, nice job right there. We can call the second column like that and just look how it stays the same. And you can also put the name of the second column. So the big thing is when you're pulling positions, you have to use these square brackets. When you're using these right here, I'm going to zoom in super big. What does this do? I've got Bolt House today. Bolt House drink. What do these things do right here? Those are for functions where you'll have a function like the mean, and that's connected with parentheses, and the arguments go inside of here. So, and I have it really big so it's very clear to see that these are square brackets which pull positions. So whenever you take the mean of a vector, like if I go here and take the mean of the iris vector right here, it'll give me the mean, and I could technically choose position 1. That's because this returns a vector of length 1, and you also see these right here. So here's where you have a function with arguments inside of it, and here's where you have the position for vectors. Oh no, don't use iris. You're going to use the name of the data set. The reason I'm using this right here is because I don't have that data set that they have. Does that make sense? Does that make sense, Jamie? I don't have that data set, so I'm doing the exact same thing, but with a different data set because I don't have the iris. I don't have the what was it called? Let's look at the name of the data set. The name of the data set is li_df, and then the column is day 2. So the difference would be this would be li_df, and then this is day 2 right here. Yeah. So this is the second column of the iris data set. This is the name of the data set, which is just like an Excel spreadsheet, and this is a column inside of it. And just so we can view what it looks like, I can make it appear in the global environment. This is stuff you don't need to do. I'll show you the exact code you need to do. But I think it just helps to understand that we're just taking this column of data right here. This is the second column. And when you look at the code we're running, it literally is telling it to take the second column of the data frame. Don't worry about doing that, just makes it appear. So we only need 1 of these. My personal favorite, if it says take the second column, I might just do that right there. That, if it says take the second column, that's good right there. If I had, so what's going on right there? How is it treating? Let's write this down right here. If I put this right here, how, I want us to think about what is going on right here with this. Let's look at this code. And how is it treating iris net right now? It thinks iris is a what? When it sees parentheses right here, so this is like the big important things, like it's like learning to speak a language. Kayla, nice job right there. Let's throw 20 points to everybody. Good interaction. And does that make sense, Jamie? That when it sees the parentheses, it thinks that iris is a function. But iris is actually a what? Iris is a what? What kind of object is iris? Iris is not a function like mean is. So mean is a function. And so you can see right there, it's a generic function. And when you have functions, you use parentheses. But iris is a what? And you can see kind of the image right there of what it looks like. So iris is not a function. Iris is a what? Just like your object too. Data file, a data frame. Does that make sense, Jamie? That Exactly. Nice job, Jamie, right there. It's data frame. And data file, same thing, Excel file. And you can see kind of the image right here of what it looks like. So if you put parentheses on it, it's going to treat it like it's a function, and it really doesn't know what the iris function is. And it's like, could not find function iris. So it doesn't make sense to it when you do this. Also, we'd have an issue. Yeah, nice job, Jamie. And then, so with functions, what would you be doing right here with this function? Like explaining words to somebody why this would probably be a bad idea with this function right here. Because what have you done to this something in a function? You left it and it's a blank. Like I mean, it's the first one. You've left something in a function, which you generally don't do. You left it blank. Nice job, Catherine. And you've left an argument blank. So yep, Kayla, yep, and everyone's getting this is the lingo. We're basically learning how to speak our. So the reason, and just to review, let's go back in time. So wow, perfect. Except for this. So any of these methods are fine. All of these methods produce the same output. My personal favorite is to use a $sign, but you can still reach the columns in the column space right here. So this will, if you notice right here what I have, you can also view it visually right here. The $sign is just one way to get to the column space or the vectors inside of there. The second column can be achieved here, or you can put in the name of the second column. Does that make sense, Jamie? How all of these do the same thing. Like you don't need to do all three of these. This is all the same thing. Like it's just three ways to achieve the same goal. So if someone says take the second column, I would do this because they haven't told me what the column is. If someone says take supple width, I'd probably do this method. So my two favorites would be these two right here. I'd prefer if someone says, take supple width vector or take the supple width column, I would use this. If someone says take the second column, which is supple width, I would do this. It just depends on how you're talking about it. All achieve the same goal. So with that, and we're just storing it into second. And great job. So good to see you here, Catherine, just working out the problems. Build a logical vector true if the value in second is extremes, and then it has extreme is greater than this or less than this. So we're going to do the same thing. We're just going to do a logical. Now, once again, we code in little bits. That was too loud today. Little bits, like screaming little bits. So we have second right here, and we're just going to look at the vector because we're making up our own example of this. So we're going to go, we want it to be greater than this or less than this. Okay. So greater than 4 and less than 3. Okay. So let's do it's greater than 4. There's that. And you can see the ones that are greater than 4. And then you could also do second less than 3. You see there's the trues. And when I combine these together with an or, if anything was true in either vector, like this one right here, this 9th position was probably not true here. Oh, it was. But if anything was true in either vector, then it will return true. Does that make sense how this vector, and just to make sense of this, true, we need to do a vector. True, true, false, or false, false, true. Okay, so what will this return when I run this code? What will this code return right here? We're understanding what that code does right there. Like how connecting things with an or works. Exactly, Kayla. Nice job. It'll return all trues because it's going to say first, it just needs one true when these are matched. It's going to go through and match pair by pair. And if we were to change this to false at the end, it would do this. Now, what will this? See, this is a good test question. Would you like this as a test question? What will this return? What will this return? Good test question, I think, right here. And now we see how to use an and. Nice job, Kayla. You got it. False, true, false. Because it's just going to go through and it needs to have two trues to match it. We have really good notes on this. Kayla helping out with the notes on this. So here's the notes on it where you can see for things with an and to have a true, you must meet both conditions. And an or, there could be 3, 4, 5 conditions, but an or just needs at least one true. So as long as one of the two is true, or like if you have 10 things, if one of them is true. What's up, Alexander? So good to have you here. Hey, you're doing excellent in 201. If you want to take 320, yeah, we love it. I love coding and all this stuff. It's so much fun. Hey, Catherine, it's like I don't mean it's bad. Sometimes you guys see things like 5 times, like because that's literally the story of my life. The first time I saw logistic regression, I was like, this is ridiculous. And now I think logistic regression is so easy, and I'm like, how was that ever hard? And then I have to remember back to be like, I had teachers try to explain it to me, and I was like, I just don't get it. I don't get it. And then all of a sudden it just clicks. You're like, well, that makes perfect sense. And then it's like, how did I not know this? It's like, try to remember like learning your times tables, like your 5 times tables. Like I'm trying to teach my nephew Tolliver mathematics, and I'm just like, what's 5 times 5? And he's like, I don't know. And I'm like, it's 25. It's like, how do you know that? I don't know. I've done it 100,000 times. What's 5 times 8? 40. It's like, yeah. You know what? You can do some cool tricks. You know what's the easiest trick? What's 5 times 30? 150. What's 5 times 32? 160. If you divide it in half and then add a 0, I just realized that. What's 5 times 82? 410. Huh. Did anyone else know that? I don't know. I'm done. Okay. Enough about math. Math is cool. There's a really everyone knows the 9. Kayla, you know the 9 times trick. I'm sure you know this, right? Kayla, where you do the 9 times trick. Well, I have to do it with this finger, where you do like 9 times 4 is 36. You just count up your fingers. But if you change the base, you can actually do it in different base mathematics, because if you do like your so this would be the 4 times table, and so 4 times 2 is going to be 8, because you count this as a 4 because you're in base 4 mathematics, and then this would be 3 right here. So 4 times 2 is 8. You can even do like so this would be, I don't know, I'm done with it. But if you change the base of the mathematics, you can actually do any mathematics table with that amount of fingers. This just assumes base 10 mathematics for your 9 times table. And so you could do your 7 times table with base 8 mathematics. I one day figured that out, and I was like, what? What's up, Everest? Good to have you here. I'm done with that. Example over. All we got to do is sum it up now. Okay, we're good. Let's sum it up. We're just going to take this. What does putting a logical inside of sum do? I know, it blew my mind. I was like, what? What does putting a logical inside of sum do? What does putting a logical inside of a sum do? So logicals are trues and falses. Trues and falses are seen as ones and zeros. So now we want to see if whatever we have stored in the object second, if it's greater than this or less than this, and this will tell us how many whats there are. Like, just describe to someone in words. If we do a sum of a logical, it will tell you how many blanks. Always try to think of it as words. Like, just don't think of it as code. Just think of it as, oh, we're just telling someone how many blanks there are in this vector. Exactly, Kayla. Yep. How many trues? So it's how many trues, and then we should also know the percent of trues. I'm going to put some hashtags next to the ones that are key for this. So Jamie, the ones you really need for this question will be this. And I think they have you do this. So the ones I have hashtagged right here are the ones that are basically the required ones. And also show the solution. Does this make more sense right here, Jamie? As we go through like what this is doing, this is going to tell you how many trues there are. Solve it with a one-liner. You could just take because once you put it all in one line, did I not do that one? Part to solve with a one-liner. So let me solve with a one-liner, not do all those steps. Okay, so I'd take this right here. That's the vector. I'm going to see if the vector is greater than 4, or the vector is... I would not sign it with a one-liner. I would not do that. It's not... I'm all about little bits of code. Little bits. And we should get 60. The answer is we get 60. So that's how you would solve it with one line. It just, to me, it's easier to put it in parts to check your work. They just want to see if you can put it all together. And so that's all one line right there, not creating a new vector with the iris supple width and not checking your work. But that should do it. And great questions. More questions, and we can do the visualization here in a little bit. Put that in the video. What questions are there? That was really good practice right there. We're going to do some practice sessions tomorrow, I think, too. What questions? Feel free to ask. We'll head over to the visualization here in a moment if there are none. But yeah, Ryan, go ahead. Of course. I jump around. I kind of take highest priority, like definitely like the nearer the, don't worry, Sarah, I think I'll have time to talk about the, don't worry, Sarah, I'm gonna talk about the decision trees here. I try to be as equal as possible. It's tough. It's tough. Go ahead, ask away, Ryan. It's like, especially this DataCamp. Juice. General background on loops. Yeah. Are you in yesterday's class or today's class? Thank you, Sarah. We did it a lot in yesterday's class. Yeah, no. Which one are you struggling with? Today's perfect. We like if you ask, I think Kale's in yesterday's class. It's so hard to remember like who's in what class. See, if you teach in person, you get to see people, but I see names and then it's just like I log online and so I'm always in front of like computer, same thing. Got like change the lighting again today. So we did a lot on loops yesterday. And here, I'll show you some of our examples. So this is everything we did yesterday right here. We did, oh man, this was like, we have a function right here, mostly for loops. Okay, just name, and then here we're gonna do some loop examples right here. Name a year, enter. So this function says, don't tell me the year you're born. Like you don't have to tell me the year you're born, but just tell me a year right now. Like tell me a year. 19 what? If you say like 80, it'll say like, please enter a year that is 4 digits and not a joke. 2000. You are Gen Z. So interestingly enough, this does have a loop in it. So it has a while loop in it right here. So I just want us to think about what happened with this while loop right here. So look at the context. It says someone is inputting year. So what does a while loop do? Okay, ready? Write down this definition. A while loop will run as long as a condition is met. A while loop will run as long as a condition is met. Does that make sense? A while loop will run as long as a condition is met. So what would happen if someone really is mad at me and they're like 80, 80, 80, 80, 80, 80? Do you see, where am I right now in this code? The code first starts off and I variables. So let me fix that. I don't know why I have variables in here. There we go. Just never changed that. There we go. I was like, I never used that. So 80, 80, 80. I think you could, oh, it got mad because there was an NA right there. So I could do if NA, but it was a missing value, so it got mad. So there's still things I could have to do. I started in CS, and this is bringing back nightmares. No, Jacob. How important are loops? How important are loops, Jacob? Jacob knows what we're talking about right here. How important are loops? Ooh, this is gonna say like it's gonna say you're an alpha gen. If you were to do this, it would say alpha. Oh, it says null. Do we not put in a value for that? Oh, less than or equal to. It returned back nothing. Extremely important, exactly. So you see right here, because we went outside the return of what this gives, it returned back null. You know what we could do? Let's do something right quick right here. If, so we're just gonna add another if. Or we don't need the else on this. We could just go to if right here because we're gonna go to else and just do another if right here. If it is greater than 2021, we can say, haha, you're funny. Okay, so now we added in this, and let's take a look at what's going on because the while loop's pretty important right here. I didn't fix the error but now if someone says this, it says, haha, you're funny. 1980, boom, 1980, it says you are Gen X. Does that make sense what's going on here? Like, let's just make sure we understand what's going on in this code. Like, just look at the simple part of it. It first says enter 4 digits. That's what's appearing on the screen right here. So that's what happens when this code runs. And then it runs this line of code right here, which stores into year a numeric thing. And it's going to ask you, what year were you born? So it's asking you this right here. And then, thank you, MeBot. You're always there to help. It's asking you this. And then whatever you input right here, this will store into year. Then it's going to look at, I can understand how this code, lapply, but we need to yeah, let's do lapply next. Lapply, the apply family is crazy important because applies have a loop in them. It makes me think of Sheldon on Big Bang Theory. Coding is so cool. It's like a superpower because like you can be like, I can solve that. Let me just code it for you. So really, really is helpful for a lot of things. And that's what Jacob might have, like if Jacob tells you about computer science, like loops are some of the most important things you'll ever learn. Like you want to do a task, you want to do it 1,000,000 times, run a loop. And then instead of writing the code, I think it's after you do something 3 or 4 times. If you can do something twice, usually just code it twice. If you can do something 3 or 4 times, then you might automate a loop. So it's funny. I was talking to someone about that over break who's major into coding. So what's going on? I want you to look at that code up there. What's going on with this right here? Why am I not getting something new on the screen? Why am I still seeing this right here appear? It still says, please enter your year that is 4 digits and not a joke. So you see, please enter your year that is 4 digits, not a joke. And then it runs this line again, which prompts me for a year. Why is this continually, I'm not leaving this? Because what is this evaluating to right in here? I want you to think about what this evaluates to when I enter this. When I enter this in here, what is that line of code I have highlighted up there evaluate to? What is that line of code up there evaluating to? That line of code up top is evaluating to what right now, every time I do it? Yep, Kayla, that's exactly right. Does that make sense, everybody? That line of code, because every time I enter in a year, it's going to look at the year, and it's going to just keep me stuck in here. It's going to continuously, I'm just going to stay stuck in this loop right here, and you can tell where the loop starts and ends right here. And we'll do a simpler version of the loop. So let's talk about the while and the for loop right here and do a simple version of it. So let's go up here and do a very simple while loop. While true, print coding is awesome. Once it evaluates to false, what will this code right here do? What will this code right here do? This is one of the most simple things I could put on the test probably. And I'll put some level, this is a level 2 question, I'd say. Explain in words what this code does. This is a level 2 understanding while loop code. Because as long as you know how a while loop runs. Could you hear that, Alexander? You could be the once and future. So what is this going to do right here? What does this code do? Explain in words. That's the test question. It says, explain in words what this code does. So a while loop, I'm just going to explain what a while loop does. A while loop takes a singular condition, and it's going to... You're really close, Jamie. You're really close. So, but, oh wait, so Jamie, let me expand upon that because I think we can get you to the right answer. Will this true ever change? This true right here that is static, hint, hint, hint. Will this true ever be something other than true? Will this true ever be something than true? And Jamie and everybody and Alexander, we're throwing another 10 points to the chat right now. Because I appreciate all the... Exactly. And Alexander, whenever you're getting it. This is always going to be true. So how long will this print for? How long will this print for? And so Caleb put it correctly. Because it's static code exactly. And it's just going to stay like that. So it's going to print forever. Nice job, Ryan, right there. So this is just going to print coding is awesome forever and just destroy my computer. Click stop. Be very careful running that. It just makes your computer mad. So let's go right here and let's add in a counter. Sometimes you do this to while loops. You might end in like I plus 1. And then we go here to I, set it to 1. And then we say while I is less than 20. So if you notice, my loop stopped. And let's make it smaller so it's easier to view. And we're going to reset it and run the loop again. And look at this. Now, why didn't it run 5 times? Let's go to a very simple version of it with 3 and say, why doesn't it run 3 times? And let's run the loop in our head. You ready? When the loop runs, what is I currently equal to? Oh, so I is just a placeholder for a variable, and I is just a object in the global environment. So we can just see it right here. You could call this counter. So usually I is just the quickest thing to type, and a lot of times we use it for position. So right here, I'm just doing a counter, and I want us to think about, and people I think are answering what this starts out. Does that make sense? I think everyone's on track with the example right now. So with this while right here, it's gonna look at counter right now. What is counter currently equal to? Great job, Ryan. What is counter currently equal to? Counter right now is equal to 1. So what does this mean this statement evaluates to? This statement evaluates to what now? Like, what will this statement evaluate to? This statement will evaluate to what right now? Because the counter is 1. It'll evaluate to true. So what does that mean now? That it evaluated to true, what will this do? Yep, great job, Alexander. Yeah, see, Alexander, you're going to be like, if you do all this, you'll be way ahead of the game. So that means that it's now going to run this code right here. So it prints that. And then what's going to happen here is counter is going to increase. Does this make sense? Now counter has increased. And then where's the code go now? It's a loop. It's a loop. That's a hint. It's a loop. Where's the code go now? It's a loop. So since it's a loop, where does the code go now? It ran this, then it did this, back to the very start of it right here, exactly, back to the while line, and it's going to look at this, and now counter is equal to 2, and then it's going to say, okay, let's see what this is, and it says true, and then it runs this line of code right here, so it prints that to the screen, and then it runs this, and here's the thing though, now what does this evaluate to? Now what does this evaluate to? What does this evaluate to? So counter is 3, so is 3 less than 3? False. And that's why the loop stops. So if you look right here, it only printed to the screen twice. That's why when you see this happen, it only prints it to the screen twice. And so we could say, we could print, I prefer, I'm just going to change this so we can see mechanically what counter is, and we'll see the same thing. So we could go cat paste, just my favorite way to paste things to the screen. The counter is at, we could say the counter, the counter is at, and then we need to put here counter. Sorry, it's counter now. The counter is at counter, and when we run it, the counter is at 2. Oh, because wait, what? My brain broke. Oh, wait, what's going on, everyone? So move the counter to 2, and then why did we not get the second one? Really? Do we need to print paste? I wonder if that's something I don't know about for loops. Whoa. So while loops are really weird sometimes. Like I have issues with while loops, and it looks like it won't cat everything out. So you have to do a print paste. I've never done print paste before in my life till today. First time for everything. So it didn't do what I wanted. Cat paste is not outputting all the output. It's just outputting the final output. I didn't know that, and I'm just, oh. There we go. Fixed. Yeah, anime eyes. I need some anime eyes. I fixed it. I was really concerned. I was like, why is my code not doing what I want it to do? And so I want to point something out. And this is a special character right here. This starts a new line. When I scrolled back up, and I only was reading this, but then I didn't notice that it did the first line of it. But unless you put the special character here, it won't start a new line. So this is not something it does. I love new line. Exactly. Jacob knows some new line right there. That starts the new line right there. Yeah, Catherine, we'll do that next here. And then I think we'll still have time for decision trees at the end. Which homework and quiz and which question are you stuck on? I do have a whole video going over all chapter 2 homework and quiz, but we can do that next here. And then we're gonna do for loop, and then we can do some homework and quiz because that's due tonight. So I was like, if something's due the day of, I always want to get it done the day of too. So feel free to be like, hey, can you work this problem? I've got like a stem and leaf thing, or like which one you're working on, because you're here, you get to choose what we do. So hopefully this is making sense. I'm going to mention what a for loop does right now, because this is going to be big important. So whenever you do a for loop or a while loop, that I want to say something. I don't even really understand what's going on with this. Like, I mean, I hate to say that, but I'm like, I don't know what that means. What are you trying to tell me, R? That's ridiculous. I know what this means, but that other thing was pretty ridiculous. So when we have a for loop, there's 3 parts to a for loop. We have here the variable, the vector, and the skeleton. We're going to talk about this a good bit today. So, and this will really help, hopefully people are watching this to review. The variable is the placeholder that can be named anything. You can name that variable anything. It doesn't matter what you call it. So let's just call it Brian to show we can call it anything we want. It can be your name. Usually you're going to call it things like I or position like that. But you'll give it a name. You got it, Catherine. We'll do that one next. Had 19 questions. I had 5. Yeah, I go through all of them. Yeah, and so in it's bookmarked like a little kind of, so I go through every single one of them. And what does your number 4 say? Like if you tell me part of your number 4, I'll find it, because everyone will have like a different number 4 because there's randomized questions. So this right here is a placeholder for anything. So I'm just going to call it Brian. And this is a vector of values that it'll go through. So Brian will go through the values 1 through 10. Brian, which is a placeholder for the values, will go through the values 1 through 10. So who knows what this code will do right here? You got it. We'll be doing that in about 5 minutes. You got it, Catherine. Thank you so much for being here. So what will this code right here do? Just remember how we read it. Brian is a placeholder for the values 1 through 10. The code will run and loop through all the values and replace Brian with the values 1 through 10. Exactly. I don't mean this as a joke. And I think it was Catherine was saying earlier, like, just find like, I see it. I would code this, and there's a site that has something very similar to this. I think they use like position because it doesn't matter what you call this. And they're like, a very simple for loop is the following. Exactly, Alexander. Nice job. You see it even stored over here, the value. 10L just stands for 10. If you notice that, that's 10. And the L just means it's an integer value. So it changes it to integer. That took me a long time to know that. So just the difference between 10 and 10L. One is numeric, one is integer. Jacob, this it goes to, I think, 16 versus 32-bit storage. So, Jacob, are you in 320 or 201? If you're in 201, hey, if you want to do some stuff in R, you can if you want. You're probably like, no. I'm trying to remember like who's in what class. But this just 201, yep. So Jacob, you probably know like when you get into like upper level coding, it really matters how much memory allocation you're using. Like for big programs, if you can like use smaller memory allocations, that's going to be a huge deal. Like if you're doing tons and tons of calculations. So we usually are not too concerned about something like this, but the integer takes up less space than the numeric. It's just memory allocation. I think numeric has double decimal precision. Probably misusing all these things, but we don't go into that much detail on these. But the first time I saw 10L, I was like, what the heck? Yeah, that's if you're computer science, this is a huge deal. Like this is like computer science would be like, what are you telling them? It doesn't matter how much memory allocation you're using. What is the purpose of coding? Like, what do you use it for primarily? Oh my gosh. That's such a great question. Let me pull something up right here. And then, so we've talked about the basis of a for loop, and then I'm going to show the power of coding, and then we're going to hop over to Kathy. Let me show this. Class is not over. Do I have it on here? I know I have it. I'm just trying to think. Where is it? Oh no, where is it? It's no fun if I don't have it. I'm gonna find something. The things you can create with code. I mean, we're using code right now to talk on the internet. I'm trying to remember. Oh man, I'll have to find this later probably. Wait. Okay, I have another way of finding it. Got it. Here it is. Is this right? Let me pull it up right here and see if it works. Okay, I'm downloading it. And then we're going to hop over and do some questions. Okay, cool. This was something... Okay, let me see if it runs. Save selected. Why does it keep saying that to me? Okay. And if this runs... Did it work? No! Let me try one more time on something. Oh, because it needs a CSV. No! I spent so long working on this. Oh. Wait, what? Okay, wait. It's working. Okay. Okay. Let me show the screen now. Let me change one thing, though. 2 seconds, everybody. And then we're going to talk about what... Wrong thing. Okay, 2 seconds. One thing had an error, and I don't know why it would. Why is my investigate not working? That's such a bummer. Okay, I think... Good, that's good. Okay. So it's having small problems, but we'll be all right. Okay. Yeah, that's a good stuff here. Okay, check this out. So it's having little bits of problems. That's the way it goes with code. You can ask Jacob. Your code's always going to have issues. So what I have right here is a regression solver that I made, and maybe it's mad about the type of the data. Let me go back to the investigate. Really? None. So I don't know why my data is not loading, and I've used this before, and I made this. So this is a data investigator right here, and we can get the histograms for it. So we can get the histograms. We can also make the scatter plot. So these are all shiny graphics right here, or ggplot graphics for visualization. So you can literally like remove the data points to just view the linear relationships or non-linear relationships. So if you want to look at a non-linear relationship, you can select that. You can just change what variable you're looking at and look at the linear versus the nonlinear relationship. You can also get the summary of the regression model. So Sarah, if you remember visualization number, the one right before they were doing, is the data? There's the data. Oh, so why is my investigate not working? I need to look at that. But this is just a data sheet right here. Is investigate work? Oh, investigate's working. And it's got the p-value. Okay, why were you not working a second ago, investigate? Code, stop being weird. So you can sort by correlation right here. So this is chapter 6. Yes, errors are the worst part, especially compiling errors, because it doesn't tell you what's wrong exactly. So this right here is, I think, about 200-300 lines of code I've written that you can input your own data sets. So I was loading up a data set right here. And rather than going through manually, you could be like weight and desired weight have the highest correlation. So you can go down here to desired weight, and you can then go here to your distribution of variables, and you can see the distribution of the data from someone's weight to their desired weight, and then you can look at the scatter plot of the relationship between somebody's desired weight and their weight. You can look at the model summary right here. And yeah, so all of this is an interactive thing that I created from scratch, and you could go to text per day, and if you notice, it changes what the model is, and there's some sort of little bit of non-linearity right there. You can look at the distribution of the variables, and you can change the y variable right here, and it'll actively change what you're analyzing. Like text per day is now the y variable. But this was something I worked on as a project, but just really helps with data investigation. So if you want to look at the most significant correlations, and we'll actually do this in 320, we'll actually use code that I used in this. So really important stuff right there. And let's hop over to 201 now. But to the answer, like why code, reasons like this right here, that's why to code. I can quickly analyze data very quickly with that tool I made. That tool does about half of 320. You're welcome, Ryan. Yeah, and so I made that tool for someone to investigate their data. And yeah, and I sent it to other professors and stuff. And I think I just got to make sure it doesn't have any like things that are proprietary towards that person who I made it for. Because I don't know. But so yeah, that took like a month to make. Just bug testing. Jacob will tell you all those things, like there's bugs, it's just like things break, just all the problems that can happen with code. But it's fun. And then when you get the end product, and I don't know why it wasn't working for a second, all of a sudden it then started working, just code being code. Just have to have reading the right type of file for it. Let's do that question. Catherine said a Center for Education Statistics reported an average mathematical achievement score for 8th graders in the nation. The average score for each nation are given below. So let's go down here to my Pearson. Actually, I'm going to open up on another tab. My Pearson. I love coding so much. It makes things so much easier. It's like coding gives you the ability to do things that your mind can do, but do them, a million times faster. So if you can think it up, you can code it and then get it to work. And this is chapter 2 quiz, I believe. So we're going to go to replace questions. And as long as this is chapter 2, it should be good. So achievement scores below. Aha, here we go. So we have found the question. Yeah, I think it's pretty cool too. We have the question right here. So this one, I would not do by hand. If you're doing this one by hand, it's a lot of work. They do put it in order. And so one trick to this one, which is very important, go down here to the very bottom, and these numbers are going to tell you what Q1 and Q3 are. And 1, 2, 3, 4, 5, 6, that's Q1. 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. That's Q3 right there. So right there we have Q1 and Q3 and 461 and 536. Okay, so we now know those numbers. So just make sure your numbers are the same as the bottom ones. But Pearson does a little bit of a weird thing here, but they do give away those answers, and I think they do that on purpose because they know their calculations are a little bit weird. So use this to confirm the answers. 6 numbers in here and 6 numbers in here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. And now, if we want to find the median, so the median should be, we have 11 numbers. So the median is going to be the 11.5th number. And let me explain how I know it's the 11.5th number. The median being the 11.5th number, wrong pen, is because if you have 22 numbers, you add 1, and then you divide by 2, and that gives you the position. Pen randomly changes. That gives you the position of the median. So the position of the median is the 11.5th number, if they're in order, which these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.5. So there's a difference of 8 right here. So it's 15, 1, 5, 1, 8. Just in case you're wondering, we're averaging these two numbers right here. And your numbers will always be the same. So as long as you have the same length of numbers, which I think you should, you can just go in 1, 2, 3 numbers and average these. So that's kind of a good tip right there if you're doing this problem. I don't think the screen size will change it. It looks like it doesn't. Ooh, no, it doesn't change it, right? Yeah. I think we're good no matter what your screen size is. Just go in 1, 2, 3 numbers and then go between these two right here. That's the median. Know how to find the median. Plug delta info jump and give me decimals. Yeah. Tell me if that, Alexander, I can correct that. Jump for some reason gets mad with these two numbers. I don't know why. Please tell me. I think this is the only one we have issues with. Please tell me if you have issues with that, but use these numbers down here as the check for your answers. Please tell me if you get it wrong, if you think jump ever gives you a wrong answer, or my Pearson didn't correct it, or if for some reason you have a decimal that was correct. And like, I'm pretty nice on giving back points. Like, if you're like, hey Brian, I want points, I'll be like, no. If you're like, hey Brian, I entered this in, I forgot 1 decimal. But I will say this, let me put a preface on that. There's some stuff later in the semester that needs to be very exact. So sometimes I'll be like, oh, for the T score, you need to have the right thing, because sometimes people use the Z instead of the T. So there are errors that can be made. So we are going to use jump though in just a second. 536 minus 461. There's the IQR. Now to get the mean, I'm not going to do that by hand. I'm going to go here. I'm going to copy to clipboard. I'm going to copy. That's Control C. Make sure to have tab delimited. Then we're going to go to jump. We're going to go to File, New Data Table. I'm going to pause right here. File, New Data Table. Yeah. If you get it wrong like that, just tell me. So if you have the points off on one of those, Alexander, just be like, hey, Brian, can I get my points back? And I'll be like, yep. So feel free to, I don't want people spending an hour doing the same problem, being like, what's going on? Edit, paste with column names. So we're just pasting in the data. And, oh, that's an error by mistake. File, new, don't use it. File, new data table, edit, paste. If you notice the column, email me since that'll help me remember. Because, just be like, hey, Brian, you said I can get some points back. And I'll help. So please notice the error that Brian made. In the first version, I pasted with column names. And so we don't want this up here. I just started over and I pasted without column names. We now have the 22 observations. This is an error. You don't want to do this. This is the correct way right here. Thank you, MuBot. Always helping out. We're going to go to Analyze Distribution. We're going to double click this. We're going to click OK. I need to contact my Pearson about this problem and say, why does your problem take answers that are, or use answers that are not what we're getting here? And they'll say, we don't know. No, they're really nice. They're good. Like we have good contacts at my Pearson who help us out a lot. Mean of distribution 487.4. Does Brian know how to round today? That's the standard deviation. And the mean of the distribution, or the standard deviation of the distribution. Oh no, got so many things open. You know what's quicker? There we go. Standard deviation is 89.11. 89.11. There we go. Oh. Determine if the distribution scores is symmetric or skewed. Describe the middle 50%. So let's look at this. The mean is lower. This is this question. Okay, no, I see it. It's left skew. I'll be if that's not left skew. You can see the mean right here is lower than the median. You can see our little monster dude with his left skew tail. Another way to know is it's going to have negative skew. So the skewness of this, which you don't need to know this is just the extra, but it will confirm for me negative skew, which means to the low side, left to the low, right to the high, whatever way the tail goes right here. So because of that, multiple lines of reasoning, we're going to say it is skewed because the mean and the median are not approximately equal. You better not tell me I'm wrong right here. That is a pretty decent skew, and we got 100. There we go. I was like, that's a pretty decent skew right there because the mean is definitely lower than the median. And you don't actually have to visualize it, but it helps. But you can tell right here the mean is lower than the median. I've done so many of these that seeing the visualization is a big help to me. So visually, it just makes more sense to me when you look at it. Did I close it? It might be gone. That's a different one. That one has less skew. Should we do the decision tree right now? Should we do the decision tree? We are in the morning block. Decision trees are tons of fun. Let's talk for a moment about decision trees. We need a big data set for decision trees. Here we go. So when it comes to decision trees, so Sarah, this is some decision tree stuff right here. So with decision trees take categorical Ys, categorical X's, quantitative Ys, quantitative X's. What are the only things decision trees don't use? The only variable decision trees don't use is what? And they can take any X's, any Y's, like quantitative Y's, categorical Y's, quantitative X's, categorical X's. The thing we don't put in decision trees is what? What do we not put in a decision tree? That's where identifiers. Nice job, Kayla. Yes. Let's throw another 20 points to the chat right here. Identifiers. Nice job, Sarah. Yep. Great job. Points, add, plus, viewers. 20 points. So what they said, yeah, exactly. So what we're going to do right here is we're not going to put in this identifier. So we're not going to do that. Let's predict if someone's in Greek life. The quickest way to do this, and this is basically what you'll be doing for yours. I don't know if those are identifiers. I'm selecting everything. If you want to select everything, you can do that. Then you can deselect stuff by hitting Control or Command on a Mac. And I'm going to deselect the variable I want to use, Greek life, and I'm going to deselect the identifier, and then I'm going to put all of these over here. So all of these are going to have the chance to explain the Y variable, and the Y variable is going to be Greek life. So I'm going to try to use all of these right here to explain Greek life. Does that make sense? Like everything's going to get a shot. So we're just going to click OK, and here's the decision tree. I'm going to go to color points. It's a categorical variable, so we're doing what's called a classification right here. How did you get to the decision tree? You'll go to this arrow, you'll go to Analyze, you'll go to Predictive Model, and you'll go to Partition right there. Help me do this, Sarah. 2 seconds. Watch this. Zoom. You will go to Analyze, Predictive Model, Partition. There you go. Almost out of juice. That is how to get to the decision tree layout. And in the decision tree layout, wrong button, in the decision tree layout, you have the X variables you're going to use and the Y variable, generally just one. I've never used it with multiple Ys. I guess it would just make multiple decision trees. You have the X's you're going to use. It's important to have a lot of X's just so you can see what mine had in it. I should be able to go to redo, relaunch analysis. Oh, no. I wanted to go to relaunch. I didn't know about these buttons for a long time in Jump. But you can see what I put into the X's right here. There's a ton of X variables. So let's think about what a decision tree is going to do right here. So what a decision tree does is, and we'll just keep this output over here. That's good right there. So with this output over here, here's the decision tree that's made from running this code. And the decision tree is trying to classify people as Greek life or not Greek life. And when the decision tree runs, it's going to look at every one of these variables and find the best variable to split on. So it's going to look at all these and be like broken bone, family order, GPA, and it's going to look at all of these and it's going to find one of them. And it's going to say the best variable to explain. Right now, the best variable in the data set to explain if someone is in Greek life is how many Facebook friends they have. And if somebody has greater than or equal to 370 Facebook friends, here's the probability they are in Greek life. If someone has less than 370 Facebook friends, here's the probability they are in Greek life. This is 357 students, and this is 449. And the Gini index is, you don't need to know this one, but this is the log of the p-value. It has to do with significance. I actually looked it up last semester because everyone was like, what does it mean? No, that's the log worth. The log worth is oh, and it's telling you the p-value of the split right there. Okay, that's the p-value of the split. The p-value of this split is ridiculously significant. So you can get the significant, you don't, that. But this is the p-value, and that's the Gini index, which is the impurity. That's the impurity of it. Gini index is impurity. Don't worry about Gini index impurity. We get into that in 474. So in the log worth is a p-value on log scale. You don't need to know that. But if you were to split here, you would get a log worth. So now we get a log worth of that split, and this is very statistically significant. So I want, for just a moment here, us to think about, I'm just going to split in these spots. Who are the most likely people to be in Greek life? Who are the most likely? Remember, blue means Greek life. Red means not Greek life. Who are the most, I just want you to describe for a moment the most likely people to be in Greek life. The most likely people to be in Greek life, and you will get something like this when you do the decision tree. If you want to send me your work or anything, I mean, we're not going to leave yet. We're not going to leave at 12:30. We're going to hang out for a little bit. Who would be the most likely people? Remember, blue means Greek life. Red means not Greek life. Who are the most likely people to be in Greek life? It doesn't mean they are in Greek life. It just means you're this group. If you were to meet these characteristics, you'd be the most likely. Because, Kayla, you're close. So it's going to be... there should be a color points icon up here. So when you do this, there should be a color points icon right here. Kayla, you're super close. It's going to be people, so follow the tree this way. And so there's one thing you wrote. Switch the first thing. You're super close. Alexander, you're super close too. It's going to be people who have greater than or equal to 370 Facebook friends, and they have less than 16 hours weekly worked. Does that make sense? Just follow it this way. And this group right here has the most people. We can also see this if we go what's called the leaf report. The leaf report is going to just tell us these leaves at the bottom right here. And you can actually see the first leaf right here, which has 56% in Greek life. Yeah, no worries. So you can see right here. I might have to make it smaller. One button. Oh my gosh. There we go. So you can see the first leaf, and there's 114 people here, and there's 183 people here. And what about this leaf over here? This leaf has 26 people who are in Greek life. There's 26 people right here, and there's 117 people right here. So this red bar right here is 117 people versus the 26. And I think one thing, and I'm going to have to make this a good bit smaller. Let me close up this window because this window's not needed anymore. One thing I really like to point to when I do this, I'm going to make this really small right here. Sorry, you're not going to be able to read it for probably a second. I wonder why that text is not changing. Trying to get this all on one screen. That is so close. Oh, we need to go up higher. If I can get this all on one screen, it really helps to see it all at one time. Okay, there we go. Let me screenshot this. And let me show you something really important about this. Okay, let's bring it over to Word and let's edit it. Okay. Okay. So with this, I want you to notice something. Sure, I think black will work. 1, 2, 3, 4. Also, what does that top graphic look like? What is that very top? So Alexander and Sarah and everyone should kind of know what that top graphic looks a lot like, because it's categorical. We're trying to predict if someone's in Greek life, and then we're putting people into groups. And so you have like group 1, group 2, group 3, group 4. So you have a categorical by categorical variable that has now made a what? Mosaic plot, exactly, mosaic plot. So that is a mosaic plot up there. And then down here on the bottom, do you notice how this right here is group 1, group 2, group 3, group 4? So when you look at the distribution of this variable right here, you're actually looking at this right here. That's the same thing. That is where a lot of people are at. There's 324 people total in this group, and here's the distribution of that variable, and you can see it up here also. Then it's important to realize, I'm going to zoom in so I can type better on this, that this right here, this is group 1, group 2, group 3, group 4. Group 1, group 2, group 3, group 4. And you can see the distribution of this variable right here with the counts. And you can see the distribution with the percentages right there. Does it make sense how all of this information is now connected? That if you want to look at this group right here, this is group 4, which is the fourth terminal leaf, the very bottom one. There's 203 people up here. Here's the distribution of the people who are in Greek life, the people who are not. These individuals are people who have less than 370 Facebook friends. They are economic, their political economic views are moderate, liberal, or very liberal. And there are, group 4, there's 26 of them that are in Greek life, and there's 177 that are not. And that's the distribution of this variable right here. Is that making sense? Great job, Evelyn and everybody. Is it making sense how to connect these graphics and what you're seeing with this? This is like, we've actually covered most of the chapter. If you understand this, you know what like a leaf report is, which tells you the ends of the tree. Think about leaves. Like think of this as an upside down tree, and these are the leaves of the tree. And here's the leaf report, like the report of what's in these leaves, which just tells you this right here. Awesome. Yeah, this is, we've covered most of the chapter with this. The only other thing for me to say is really 11.6% of the variation in someone being in Greek life is explained by the decision tree. In literally 10 minutes. That's like a 10 minutes clip notes on this. Like you should know what R squared is. But yes. What questions are there? I feel like the room got... Oh, I know why. I didn't turn on the main light today. That's why. That's why. What questions are there? Final questions of the day. Let's put on some music. Let's put on some music. I don't know what to play. Chill music. To end the day. To end the office hours, not the day. 2 classes and the office hours remained. Hop back here to space. Yes. I put my question on Discord. Let me take a look at the Discord. Let's take a look. I got time. Here we go. I'm having trouble with the using this code. I just don't know why the function to lower does not need inside the... Oh, yeah. Okay, let me grab it right here. Let's do this one. Hey. Let me grab it. Okay. Let's go back to the main screen. And let's take a look. Okay. I don't think I have any... Did you do the bivariate displays on the Monday? Yep. Or it might not be on the Monday ones. Are you talking about chapter 3 or visualization 3? If you can't find the video, let me know. And every video is labeled. Like if you go through them, every video is labeled. So double check and see if you find it. So this is dealing with strings right here. The vector pioneers has already been created for you. So it's a string vector. Split names from birth year. You're doing a string split based on that, and then you're saving the vector. Convert to lower strings. So okay. And then you're applying it using lapply. So let's do a very similar thing right here. And you're doing that. Convert to lower strings. Okay. Is it not liking this code right here, Kayla? So we can do something very similar quickly. Let's go here to vector. And let's concatenate. And we just need a few. Let's just go here. Brian, 1982. Adam, 1981. And now, my thing's still running. String split. String split. That's in string are good. I'm going to do string split, vector, good. It's putting that right there. So it's returning lists. So this is returning oh, you know why you don't need the function parentheses. Oh, yeah. I think I know what you're saying. So you're saying, and let me just store this as output. Great naming. That's it. Output a list right there. And then lapply applies a function to a list. So here's I think you can maybe do that. Let's go apply to the output to lower. And so it does that right there. And I think you can put this. So it's really interesting the way this works. It's mad about the parentheses. Kayla, if you have a better way of describing it, when the way these functions work right here is it will take and it will it'll run this function on it. It'll like apply this function to whatever's on the list. So instead of you going here, like what this does is it goes here and it goes to the output. And since it's a list, we need to use double brackets. So it's going to do it to every element of the list. Like this is what this code does right here. It applies the function. So basically you're not inputting the function. Like I'm trying to describe it as best I can. Like this helps me trying to like explain what goes on. So lapply takes a list and then it says, what function do you want to apply to the list? So then it's going to do it to every element of the list and it'll run this code for you. Basically it's a loop. So what's really going on in the lapply is it's going for, can we do a length of the list? So if we do length of a list, 1 through length. So what it's going to do right here is, and let's call this position. So what lapply does for you is it runs the following code. It's using two lowers, so we could go right here. So if you have a much longer list, object I does not exist, so I use position. I use I all the time. So, and then we want to print this right here. We'll just print it for the moment. And that's that, and that's that. So this is what lapply is doing. It's going through every element of the list. So it's a much quicker way than with this code right here than to constantly make a for loop that will then apply a function and change the element of the list each time, because you could have a much longer list. Like if we had a list with, we'll just repeat this vector here with a whole bunch of stuff. No. So this is much longer now. And you can see here, if we use lapply, it'll do it to every element. And if we do this, it'll do it to every element too. Does that make sense, Kayla? That so the reason you don't use the parentheses is it's going to kind of fill out the information for you. It's basically just saying, because you're not actually running that function on anything, the lapply is then going to utilize that function for you to do the looping on it. It's like it'll create the code for you, which is interesting. Like I know it confuses me, like, well, why wouldn't we put this as a function right here? But you're saying use this function. You're not actually going to put the inputs. It'll then create a loop with the inputs. I hope that makes sense. I'm going to let more music on. Let's go here to. I think so. Kill, I probably need you to explain that to me. I'm so bad with the f of x stuff. That's where my brain started to break in mathematics. Like if you write something down like on the Discord or in the email, yeah, because so f of x is just y. That's like just because. So see, I'm so like for some reasons there's just something that's not clicking in my head. It's just like saying y, right? It's some y is some function of x. Like when we do like an equation, like if you do like y equals 2x plus 5. So this would be the same thing as like f of x. Like what's mad at? And I don't have x in here. It's true. I'm being right that way. So because this is, and we can't probably put f of x. See, we could define a function f. You could define a user function f. I don't think f is, lowercase f is not a reserved word. So it'll input some x. And so you have to input x. My brain's breaking. Like, because now we'll have a function and you input x. Yeah, and then you could put this equation right here. And then you could hit return. You could have a user input function. There's other ways to do functions that are like, that's when my brain was like, wait a minute. So now this will return this, and then we could do f of x, which is going to be, if we just input here, but see now we can put in like 2, and it'll output that. So that's going to solve the user. We've already defined the function up here though. So you could say to someone, you could have a user input, like define your function. F to lower than fx, wait. F equals to lower than f of x to lower x? Oh, you're like explaining it. There's just, see, like, maybe it's just, I don't know. You gotta learn things early, and then it makes more sense. It, like, just Brian ranting about coding and learning for a moment. It's just like sometimes, like, I think that was my problem in mathematics, is like some things didn't click. And I'm gonna say something sad here. I had a teacher. So f equals function equals to lower. So it's performing an operation, right? Okay. Kayla, Kayla, we're throwing 10 points. So f is the function, and it performs an operation on x. X is the argument. So, and it's going to output. See, okay, it's making more sense. Yeah, you have to use your framework of what you understand. You have to be like, you have to like turn into the language you know. And I had a mathematics teacher, not gonna name their name, and they were very discouraging. And they basically made it clear that they had favorites in the class. I'm gonna go more. It's good music. I like this. This is very like vaporware. They made it clear that they had favorites. Every student's my favorite who just tries. Literally, one of my favorite students, which I just found a picture with him. He came back and wanted a picture with me. He was excited to make a B. And I'm not saying you shouldn't be excited to make a B. Just, I want to tell the story of Dave here for a second. Dave took my class when he was even older than I am now. Nothing wrong with that. And he was a professional soccer player. And he had gotten many concussions. And he was like, I'm not going to pass this class, Brian. I can't remember anything. I've had so many concussions that I just don't remember things. I said, here's the plan. I was like, here's the plan. You're going to ace the homework. You're going to ace the quizzes. You're going to ace the projects. And with that, you'll have like a cushion. And he's like, yeah, but I'm still going to fail the test. And I was like, well, we're going to do everything we can to help you not fail them. He's like, I just can't remember things. I can get the work done. I can do the homework. I can do the assignments. I'm just going to fail the test. And he did fail the first test. And he failed the second test. And if he had failed the third test as far as he was failing all the tests, he might have got like a C or D in the class. And I was a little bit concerned, but I said, you know what we're going to do? We're just going to do as many practice problems as we can. We're going to keep doing practice problems. And every day he would come in, we'd just do a practice problem. We'd be like, okay, here we go. We just work through it. And I'd be like, I designed these tests. I can give you practice problems. Okay, what do we do on this step? What do we do on this step? What do we do on this step? We just turned it into steps. And he put in a lot of time. He put in a lot of work. And I think he made like a 92 on the final. And he made a B in the class. He'd made like a 50, 55. He had hundreds on everything else. But his test scores were just pulling him down. And then he made a 92 on the final. And with that, he got a B in the class. And his email back to me was like, yes, when I said you got a B. And he came back and like 2 years later, he's like, he was at the door. I was like, Dave. And he was like, hey, bro, I just want to take a picture with you. And I was like, yeah, of course. So good to see you. And see, that's the thing is like, you don't need to make an A in my class for me to be happy with your performance. You just have to, achieve what you want to achieve. So don't worry about being an A student. Worry about just putting your best foot forward. That's my motivation for today. Every student doesn't need to make an A. I just want you to try your hardest, and I just want you to ask for help if you need it. With that, practice makes progress. Exactly. Mubot's helping out there. Kayla, great having you here today. Great having everyone. If you have questions, let me know. As we always say, bye for now. Bye. You're welcome, Kayla.